This lesson is about identifying corresponding parts of triangles. So that's our objective. Our agenda is we're going to talk about vocabulary. We'll go back and look at some vocabulary review as well as some new ideas. We're going to go back to the book and do explore and reason. We'll take our notes for a couple new theorems that we have. We'll check out how much you caught from that by doing the do you know how, and then we'll work a little bit in groups and then work on our homework assignment. So let's first of all talk about our vocabulary. Let's go to your vocabulary sheet for this chapter, topic 4, and we've already done all the way through perpendicular bisector. Let's go to review of angles. What I'd like you to make sure you understand in this is when we do these angles, these are ones you've done, these are congruent angles that you spot in different parts of diagrams. So vertical angles, just a reminder, are the ones that are opposite each other. So if you look at these two angles, they're congruent to each other. Corresponding angles, we would take an angle like here, and corresponding to it is you go up the transversal and past the other line, and you've got your corresponding angle listed there that's also congruent to it. If you've got parallel lines, so you look at this one, alternate interior angles are where you look at an angle like here, and it's congruent to this one here because it's on the other side of the transversal, and it forms a Z if you look, in this case a backward Z, but a Z if you look at those two angles. And then alternate exterior, again you follow up the transversal, jump over to the other side, and so if you go with this one here, this one's congruent to this one here. Because those are on the exterior of the two, but on the other side of the transversal. So just a reminder, those are ones that we've dealt with before. Those are congruent. When you have vertical angles here, if you have parallel lines, you've got several congruent angles. We'll use that because we'll need congruent angles in some of our proofs. Included angles, what that means is, it's the angle between two sides. So a diagram, what that would mean is if I draw a triangle here, I've got a triangle like this, if I'm dealing with these two sides, this one and this one, where they come together, this angle is the included angle. So it's the one between them because they meet at a point where that angle is, okay? So the included side on the other hand, the side between two angles, we'll use soon, not in this lesson, but soon, the side between two angles, if I've got my triangle, if I've got two angles like this angle and this angle, then this side connects those two angles. So this would be the included side, the side between the two angles. We're going to talk about included angles and included sides quite a bit with congruent triangles, so you need to get used to being able to find out which one it is. What I'd like you to do now, going back to our agenda, you're going to find the agenda in the announcements. So if you go to the announcements for today, so it's Geometry 4-3 Day 1, you click on that announcement, you've got your list here of what we're doing, click on the Explore and Reason, pause your video now, go to the agenda, click on Explore and Reason, give that a try, and talk it over with your partners. So next on our agenda is to try some notes on theorems that we're going to use to prove triangles congruent, and also sides and angles in congruent triangles. So let's go to our note page here. So when we go to this, we're going to fill in this information here. These are going to be critical theorems for proving triangles congruent. So let's start with side, side, side. All that means, when we abbreviate it SSS, that means it's going to be proving a triangle congruent by finding all three pairs of corresponding sides congruent. So all three pairs of corresponding sides are congruent. That means that the triangles are congruent. So here we've got two triangles. Got this triangle, I'll call this ABC. And then I've got another triangle over here, DEF. If this side is congruent to this side, those are the corresponding sides. If these two sides are congruent, and then if these pair of sides are also congruent, so we've got all three pairs of sides congruent, that means, so all three pairs of sides congruent, that's our given, then we can conclude that the triangles themselves are congruent. So we can say that triangle A, B, C is congruent. Now we've got to do it in the corresponding manner. If I go from A up to B, I've got to follow along here the same direction. So I'm going along the single tick mark up to the one toward the 3. So it's going to be D, E, and F. You got to make sure those letters are in order, okay, for doing that. Now that's the first one. All three pairs of sides congruent, then our triangles are congruent. Another one is side angle side, and this angle, because it's between the two sides, that's that included angle we just talked about. So two pairs of corresponding sides and the corresponding included angle you have those congruent, that means the triangles are going to be congruent. So let's draw another diagram here. So let's say we've got this triangle. And we're going to try, we'll name this W, X, and Y. All right, and then we got another triangle here. And let's say we have this as M, N, and then P. All right, so if we name like this side congruent to this side, okay, over here, and this side congruent to this side, the included angle between those two are X and P because they come together at that spot. So if these two angles are congruent, then we've got side angle side to show that these two triangles are congruent. So what we do is when our conclusion will be that triangle, if we go WXY, is congruent to. Now be careful, I didn't put them in alphabetical order here. You have to follow along that single tick mark to the included angle, so MPN for that triangle. So make sure you put it in the corresponding direction. So that's a theorem that we also can prove those two triangles congruent. What's nice is, remember, congruent triangles means all the sides are congruent, all the angles are congruent. So if we start here, we can say all the sides, all the angles. But what if we want to prove a triangle congruent? You'd have to prove 3 pairs of sides and 3 pairs of angles. These theorems are a shortcut. Instead of proving 6 things congruent, you only have to prove 3. Either all 3 pairs of sides congruent, then we know that the triangles are congruent, and then the angles are congruent. But if we also do side with the 2 pairs of sides with the included angle, it's a shortcut for getting the rest of the triangle congruent. So these really are shortcuts, so we don't have to prove everything's congruent. Now, corresponding parts of congruent triangles are congruent. We abbreviate that CPCTC. It says if 2 triangles are congruent, then each pair of corresponding sides, are congruent, and each pair of corresponding angles. So this is going the other direction. We start knowing that the triangles are congruent. So if we start with the given being triangle ABC is congruent to triangle, let's say Q, R, and then M, all right? So if this is what we have as congruent, we can now say all the corresponding parts are congruent. So we can do the angles. We can say angle A is congruent to the one corresponding to it. It's listed first, so that's angle Q. We've got angle B will be congruent to the angle in the middle here, angle R, because they correspond and where they're listed. And then angle C corresponds with the M, angle M. We also know pairs of sides are congruent. So if I list the side AB, so segment AB, that's going to be congruent to the first two listed together, QR. If I list AC, that's going to be congruent to the first and the last, QM. And then lastly, if I go BC, that means that RM are congruent. So there we have all the listing of all the corresponding 6 parts, the angles and the sides, once you know the triangles are congruent. So the first 2 theorems are shortcuts to prove the triangles are actually congruent. This one is, if you know the triangles are congruent, what corresponding parts are congruent in the angles and sides. So there really is an importance here in the word corresponding. Okay, so let's do some example problems here. Let's try these, the importance of the word corresponding. So looking at here, we've got ABC to DEF. Take a moment, pause the video, and try listing all the corresponding sides and then all the corresponding angles. Do the same thing with this one here, corresponding sides and corresponding angles. And when you're done, go ahead and restart the video and we'll take a look at it. Let's take a look at what you got for these. All right, so this, we have corresponding sides. We list the first 2, AB, correspond with the first 2 here, DE. The first and last, AC, is going to correspond to DF. Okay, and then if we do the last 2, BC, those 2 are going to correspond to EF. So those are our corresponding sides that are congruent. Let's do the angles. Now we don't have to list 3 letters for the angles unless there's other things involved. We'll talk about that tomorrow. But here, angle A and angle D line up. So we just say angle A congruent to angle D. Then we say angle B is corresponding to angle E, because they're both in the middle, and then C and F line up. So there's your corresponding angles. Here, let's try this one. Again, start with the first 2 letters, G, H. They're going to be corresponding to WU. Then we're going to have GJ corresponds with WR. And then we're going to have HJ, the last 2. They correspond in order with the last 2 here, UR. There's our corresponding sides. Let's do the angles. First with the first. Angle G with angle W. Angle H with the angle U. And then angle J with angle R. It's really important that we have those corresponding pieces together. All right, now here we've got some measurements. I want you to take, again, and pause the video, look at this triangle and that triangle, and don't look at what it looks like are congruent on the diagram. Look at what it actually says is congruent by the triangles. Look for corresponding angles and sides, and list for me what these measurements are. So pause the video, give it a try. Now that you've tried it, let's take a look. Now notice when it says MN here looks like it's actually congruent here to BC. Let's look over here. MN and BC are listed in the same spot. So MN and BC, now this one's going up and down, but it's that one there. So MN is the same as that length, so it's equal to 8. PN, on the other hand, notice that I'm not quite sure which one is it congruent to. We'll go to your congruent triangles. P and N are the first and last, so it has to be congruent to AC. If you go over here, AC is that length there, it's the 22. And then lastly, when it says the measure of angle M, I go over here to see what corresponds with angle M. It's angle B. So I go over here, find angle B, and that's 75 degrees. So use the congruent statement in order to decide what angle or side to look for on the diagram. All right, what I'd like you to do next is I'd like you to go to the Do You Know How section, and I'd like you to try numbers 6 through 11. Let's practice some of these problems by taking a look at the Do You Know How, which is on page 171. So here are the diagrams for the first three, and the question is, how do you know these are congruent, or are they congruent? If you look at these first two triangles, notice that it marks two pairs of sides with a single tick mark, two with the double, two with the triple. That means we have all three pairs of corresponding sides congruent. That means that these two are congruent by side, side, side. This next one, these two triangles here, notice that it has an included angle that's congruent, but notice it's a little tricky. These two are congruent, making this an isosceles triangle. It's congruent to itself, but it doesn't mean it's congruent to this one over here. So since these are not congruent to the side in the other triangle, neither one of these work. We don't know that if these are congruent or not from the information given. So we're going to put neither for neither side angle side or side 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 because of the difference there. This last one here, notice that single tick mark on these sides, double on these two, and then these angles are congruent, and it's the included angle, meaning between the two sides that are congruent. They come to a point there, so these come to a point at that included angle. That makes this side angle side for these two triangles. Now, these next ones, again, it asks the same basic type of question. We're going to actually answer as to what triangles, if they are congruent, and how we know it. A little bit of explanation by giving the reason. So on these three, you take a moment and you look at them and you say, for these two triangles here, if you look at these, we've got these two pairs of sides congruent, these two pairs of sides congruent, these two different triangles, looks promising, but the included angle is not congruent to that included angle where the sides come together. These are not included angles. But wait just a moment, we can get there. How we get there is what we do is we can mark these two as congruent by vertical angles. We know all the angles in a triangle add up to 180, so since they do that, if we subtract off these two pairs of angles with these two pairs of angles, that must mean that these last two pairs are congruent. This was called the third angle theorem that we did earlier. We know that this angle has got to be congruent to this angle if you get rid of the two pairs of congruent angles from 180. So we can reason our way to get to that point. That's kind of the deductive reasoning to get there. And so we do now have side, angle, side with the included angle. So we can put this here, and the triangles that are congruent, if I go with A, B, C here, it's going to be congruent. Now I got to start with the single one here. I went to the triple, so I go D, E, C. Notice C is also part of this one as well. So, but make sure you follow the corresponding one arc mark 3. So I go from 1 down to 3 and then to the 2. Follow the same pattern, the corresponding patterns in each. Now this one here, notice that we've got these opposite sides congruent and these opposites, so we've got two pairs of sides congruent. We're still missing, we need either another angle that's included, like these two angles, which we don't have, or we need the side congruent. And notice that this side here, it is congruent to itself. Tomorrow we're going to really emphasize this. This is called the reflexive property. When we say that something is congruent to itself, back from our first section, our first topic, we had that as a reflexive property. We didn't use it a lot in the first topic. We're going to use it a lot now with triangles. So what I can do is I can mark this congruent to itself, and it's a side in both triangles if you think about them separated. So here's the one triangle and here's the other one. These two triangles, if you separate them, they have that same side in common. So these are congruent by side, side, side. And the triangles we do, let's do M, N, L, M, N, L, congruent to triangle. Now I started with the opposite angle here, so P, and I went along the double, so I can go P along the double tick mark, so P, L, N for the corresponding pieces to that. All right, let's do this one here. This one has some extra information. It's got these two sides congruent, these two sides congruent, so we either need a third side or we need an angle. It does say that these are parallel. Now we can use what we talked about in the vocabulary, our angle review, that these two being parallel, I know that these two angles are congruent by alternate interior angles. If I follow this transversal up, there's my alternate interior angles. So I now have side, angle, side, that included angle. And what I'll do for our triangles, I'll start with V here. So V, W, X is congruent to triangle. So now let's take a look at these. And we started with V, so we're going to start with S here and follow the parallel, so STU for the congruent triangle. Now, I'd like you to go ahead and go to the book. I'd like you to find problem 24, and I'd like you to work on it with your group. So pause the video, work with your group on this, see if you can come up with an answer, and then come back to the video and take a look at the solution to it. Let me read the problem to us. It says following the route shown, what is the total distance traveled by the architectural tour if it ends where it started? What properties and theorems did you use to find the distance? So when doing this problem, just so you know, we're going to reason it through. I left off one piece of information so we could see the first step is identifying that these two triangles are congruent. Notice it lists here that this side is 350 and this one is, so these two are congruent. This is 300 and this is 300, so this is congruent to this one. So and then they state that these angles are congruent, so by side, included angle, side, those two triangles are congruent. So this is 200 feet here. That means that this has to also be 200 feet. So we can now count the whole distance. Now what we've used so far is we use the fact that this is, our reasoning is side, angle, side, means that the triangles are congruent. And then we used CPC/TC, corresponding parts of congruent triangles are congruent, to say if this is 200, then that has to be 200 because the triangles are congruent. And now we're just going to add them all up. So we're going to have 200 plus another 200. Then they make a turn, that's plus 300. Then they make another turn here, and that's 350. And then that's another 350. And then they finish it off by coming back to the beginning, that's 300. So if we add all those together, we're going to get here 400 plus 300 is going to be equal to 700. This is another 700, so we've got 1400 plus 300. That gives us a total of 1700 feet of what it traveled. There's our answer. So in summary, what we've been working with is we're trying to work with congruent triangles. We now can prove triangles are congruent with two theorems. Side, side, side. If you've got three pairs of corresponding sides congruent, then the triangles are congruent. Or side, angle, side. If two pairs of sides are congruent and the included angle where they point to, that's between them, then the triangles are congruent. And then, once you know triangles are congruent, you can say any pair of corresponding angles, and there are 3 pairs of corresponding angles, or any pair of corresponding sides, there are 3 pairs of corresponding sides, are congruent. And then we can solve problems, and in the next lesson we'll look at actually doing proofs.